Right. Okay. So welcome to our day 14 of programming languages. So again, a reminder, next lecture on Monday is a midterm at 2 o'clock sharp. So again, it's going to be, I think I'll stick with two. You can choose any two out of three, basically. Same approach as before. So there will be 3 assignments and you can choose your poison, basically, right? So you can see the previous year's midterms, something similar, but not quite, maybe not the same, right? So something like closure, right? One prologue. And let's talk about the homework, and I think I have to edit this to have a good, so this one I like. This is kind of cool. So we will set it to, let's see, today is 20th, right? So 2 weeks, I think, would be okay, right? 2 weeks, and that be 6th of Thursday the 6th, and I have a conference on 6th, so I won't be here on 6th actually, but so 6th of March. All right, now let's talk about this homework first. Hello there. All right, so hello there, no problem. So basic idea is this: you have a very famous Goldbach's conjecture, right? If you look at Wikipedia, basically that any even number can be expressed as a sum of 2 prime numbers, right? Again, it's one of the best unsolved problems. I don't know, do you get $1 million if you solve it? Right, it's up to like about 300 years old. No, yeah, almost 300 years old, right? Again, if you were able to prove it, right, you would be probably world famous, right? We are not going to go for that much because we'll try to see how much can prologue help us. So the idea is this, right? So here's an example, 30, right? It's an even number. 7 is a prime, 23 is a prime, right? So up to, it's been proven up to, I think, 18. So that's like, what, quintillion, something like that? Yeah, 4 quintillion, something like that, right? So our prologue program won't be able to go that far. So basic idea is this. You need to implement the predicate, is something a prime, right? Is prime n, right? So basically, it'll say true or false, basically, right? You give a number, it'll say, okay, is this prime or not, right? Probably, of course, again, remember, in Prolog, you don't really have loops as normally. You could do something, but basically, it involves some sort of recursion, right? So that's 40% of grade. 80% if you can check, it works for Goldbach, right? So you give a number, right? So it will provide, so n is the number, and L would be the variable, right? It will return 723, right? So there is a slight problem with this, by the way, right? So you'll have to work with cut, possibly, that you might get too many, right? Let's see some numbers. Let's see. Well, 7 and 10, for example, 10 is 3 and 7, but also 5 and 5, right? So you only need 1, basically, right? So now for 90% of the grade, you have 2 things. So basically, you provide 9 and 20, right? So 9, of course, is not an even number. It's an odd number. So you check 10, 12, 14, 16, 18, 20, right? And this is inclusive, right? So, yeah. So now, so for 100%, if you want to get number 10 in this assignment, it should be able to find all primes, right, that are over, at both sides are over a certain limit, right? Usually at least one of them will be very small, like 3, 5, and so on. So this one here, this Goldbach list limit, right? So you provide where you start, where you end, right? Basically range of checking, and limit is requirement that both primes are over this limit, right? So and here's the tricky part, if you want to really get 10, right? So 106, right? You say, okay, it's 53, but that's not going to be accepted. Why? Because 106 also has 3 and 103, right? So you have to discard it. That's not what we want, basically, right? So this is for the 10, if you're going for max grade, basically, right? So shouldn't be too, I think up to 80% will be pretty easy. Up to even 90, the 100, 100% will be a little bit tricky, but not too bad, I think, right? So it's basically some limits, some checking, right? Obviously, you can say, okay, and you can, of course, I mean, you can do something in Python or C. You could do your own program, right? Like a brute force search, in another language. If you want to do like, C, exactly your solutions work, right? So, and again, the problem will be, like I said, getting too much stuff. Basically, I can immediately tell you that the problem will be how to limit this, the results, right? Getting too much, right? So, in fact, I'll probably test it. So basically, I won't test over 10,000. So that's good news for you, right? Yeah. So you can link Git repo is fine, right? If you have it, or just Prolog source code is also fine, right? Or both. Of course, I like both. And I did not mention this, but of course, I like comments, right? I like comments, right? Right? Comments. I should probably add this here. Of course, as usual, it goes without saying. I would like. Excuse me. Deadline is 6th of March, so 2 weeks. Yeah, maybe I'll extend it a little bit, but not too much, I think, right? So, all right, and as usual, write comments explaining your chain of thought, right? And of course, if you use, of course, external, I mean, also cite external references, including, of course, LLMs, of course, right? LLM prompts, right? Yeah. So again, I want to see what you do with this, of course. It shouldn't be too bad, but of course, like at some moment, like I said, you get 80, I think, with just LLMs, without knowing anything, you probably get 80, but that's not, you can do better than that. I advise trying to figure out yourself first, right? So, okay. Now, today is again another one of the easy lectures, I think, because it's from the original course book. So we'll talk about the sort of, again, kind of obvious things, statement level control structures, right? Some interesting things, structures found in various languages, including, of course, C, right? So let's see. First, let me see what I ask in the quiz. So you get to see quiz. It is statement, break statement. Yeah, these are really easy. So easy quiz today. All right. Now, well, let me start GitHub on a code space on this. Okay. Okay, now authentication. There we go. And let's open the code space. Well, it's loading. Are we recording this? Yeah, we are recording. So there's sound apparently. Of course, the question is there sound input? I wonder if this actually works here, right? If there's no mic here, I wonder why this isn't. It's audio input capture. Oh, but maybe it's okay. All right, because it's turned off. Okay, yeah, it's fine. All right. So now, our notebooks on this is going to be our statement level control structures. What good things can we find about this? There's a chapter. Yeah, there's a play. There's also there's a presentation, but I don't know how good will it be from previous years. Oh, this is from the book. Yes. So yeah, again, things, of course, again, all languages need some sort of way of control structures, right? Right. So branching, right? So because why? Because of course you want your language to be Turing complete, right? If you don't have branching, right, in some way, implemented in some way, you can't have really a Turing complete language, really, right? Again, you can sort of make it obscure it, right? Right. You can obscure it a little bit, maybe, right? So, hello there. Yeah. You just we have a homework, right? In prologue. That's the news. And of course we have the midterm on Monday. Right? Nothing else. Nothing else.
When do we have midterm?
On Monday, 2 o'clock, right? No conflicts for anyone. No. Good. Okay, good. All right. So, again, basic stuff, right? Control statements, of course, we need to dictate the flow of execution, right? So, classical thing, of course, what do you really need, really? If you think about, you need just a single selection, right, where you choose between 2 or more paths, and then you need some sort of way of jumping to those paths, basically, right? So you basically need a goto. You need a conditional goto, really, underneath in your machine. You think of your machine language, right? You have a jump instruction which jumps upon some value. Again, you took some assembly, right? That's happening underneath, right? There's 0, 1, right? And you jump to some memory address. And that basically, that kind of matches nicely to the Turing, machine, right? And everything works. But of course, we don't really want to work like that. It's a pain. Remember how you did your assembly language, right? Homeworks, right? Maybe it's a little bit fun, but not something you can do every way. So early way, right? Oh, Reddit image. There's a Reddit image, and I somehow have managed to delete. Let's see. I guess Reddit is dead or something. Reddit links are dead. Let's take a look at what's happening here. Maybe now something. Yeah, deleted by user 6 years ago. Oh well. You can't see some assembly. It looks like assembly to me, right? I had some nice example, but low level, right? So, right. So some assembly required. I should have saved this, right? So, basically, it is extremely hard to read the programs, right? Because first of all, what happens, of course, is as your needs grow and your chair breaks.
Nice.
Oh.
There's a screw there.
Oh, it's like a little, like I don't know.
Tiny.
Yeah, a little. But we should probably put some varnish or something on it, and put a paper on its face. It's, fix me or something, right? So otherwise, unless you want to hurt your next class, yeah, next victim, right? So, all right. So Fortran was the first to sort of do something a bit higher. Again, if you think about it, right, we can do if you have a goto on a conditional branch, right, you can make a loop, right? You can sort of come up with a do loop, right? Do something 10 times, right? You have some kind of counter, right? And then when you're done, you jump out, right? Right? You maybe even had to do this, something like this, right? I used to do this on a Soviet era calculators, which had like 10 bytes of memory. Sorry, 100 bytes of memory. 100 bytes of memory, right? And you had only like, I don't know, how many instructions, right? And you have a counter, right? And you basically have some register where you count how many times you want to do something, right? At some point, that register is 0, right? And then you exit the loop, basically. You jump to the next memory address, basically. So that's the approach, right? So do is already a big improvement, right? Let me see some example. All right, example of show you example of Fortran. Let me load in. Yeah, Fortran do loop. Fortran do loop. Do loop. Come on, I'm lazy. Why it's not? Oh, okay. What's it saying now? Oh, there's new what the heck is happening here? There's call extensions, settings. I want to change something. What is this? Call was for, I forget what call was closure, I think, right? Yeah, yeah, extension. Let me restart some extensions here. Yeah, that's why it's not. I'll show you the fourth example. All right. Okay, all right. Fortran. And let me see, can we do this here? Come on, settings, toggle torsional mode, settings. Oh, there you go. Oh, yeah. Yeah, do it. Do 1, 10, right, something like this, right? So, yeah. And then we move on to, right, so the thing is, Fortran still was famous, right? It kept the goto, right? It kept the goto, right? Which is unconditional branching. So goto is unconditional branching. It means you just go somewhere, right? So this leads to, inevitably, as your program grows and you're using goto, no matter how well intentional you are, you're going to end up with spaghetti code, right? Jump, 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 right? Again, let me have some pictures. Spaghetti code. Spaghetti code. Programming code. Let's find some nice examples, maybe on images. Yeah. Right. No, that's not too bad. All right, this looks okay. Spaghetti code. Which one would be better? This one looks pretty bad. Yeah, some nice examples. Yeah, LabVIEW. Oh yeah, LabVIEW is a fun language, but luckily you won't have to do this in LabVIEW. Right. Yeah, this is a very interesting language, by the way. But yeah, but by itself. Yeah, let me see here. This one's good. Yeah, yeah. Let me download this here. Let's see. Copy image. I'm just going to be lazy here. Hopefully this blog still stays around. Yeah. Spaghetti code picture. Oh, maybe there's a nice, let's see if there's hallucination. Yeah, there's hallucination. That's not good, but we will put the link here. Yeah, all right. So yeah, this is very interesting. This is not Fortran, by the way, right? Example, this is a language called LabVIEW. Anyone know what this language is? No? It's one of the earlier languages, still around, by the way. It's a visual programming language. You would think of it Scratch, but actually it's way before Scratch, actually. It's used for industrial automation, for scientific experiments. And idea is, I guess the idea was that you, basically all the things you do, you can represent by drawing basically the units, right? Kind of cool. It's like with those high concept language. It's kind of cool when you start using it, right? I did some of the work like in the early 90s on this one, long time ago. I was younger than you actually, at the laboratory. But the problem is, you can see here, at some moment, this is the issue I think with most visual languages, you just have too many elements, right? And your abstraction, how do you hide things? You have to start hiding things, right? That's another thing, of course, is also you have these wires, right? Things are wired from one place to another place, right? And I think it's much even worse. It becomes worse than a regular programming language, right? You have to be very, how should I say, very organized, right? You have to make units. So you basically, you can't, you have to do things like you do in object-oriented programming or in nice functional programming. You have to make separate the concerns, limit the areas, because otherwise you end up with this mess, right? It starts quickly, and it's because, of course, it works. This mess works probably, right? But then you go from a project for a couple of weeks, or somebody else takes over, and they can't figure this out, right? So this is example in this yeah, right. Now we get to algol, right? So algol actually was the big evolution, right? So if we have blocks, right? In Fortran, original Fortran, you didn't have a block. You just go somewhere, you do something. So your blocks are sort of like ad hoc. Ad hoc would be the word, right? Here you have for loops, right? If-else constructs, right? Guarded commands, right? Multiple Boolean expressions, right? Guarded execution of statements. So 60s, 70s was this whole structured programming movement. Famously, Edgar, I think Edgar, I forget if I spelled his name correct. Did I spell his name correct? Let me see if I did. He's Dutch, right? And really, relatively, I wouldn't say mean guy. It's, yeah, correct, right, this guy here, right? So, had strong opinions about structured programming. And, well, again, so he said basically the go-to leads to brain rot, right? So we got Pascal, we got C, and we extended from C, right? We got all the modern language afterwards, right? So what's interesting enough is that, I don't know if you know, but I haven't checked if C++ has, but C actually has go-to, right? C actually has a go-to statement. Not widely advertised, right? And the thing is, it's actually used. There are some uses for it. Most famously, Linus Torvalds, the guy behind the Linux kernel, uses it. Right? There's some lower-level operations where you would make like error handling, like you don't have exceptions in C, right? You don't have exceptions. C++ has exceptions, right? Modern language has exceptions. C does not have it, right? You want to handle some errors, go to within the confines function can be a very nice saver, right? Makes your code shorter. But of course, system-wide go-to, don't do it. Don't do it, kids, right? No. So yeah. All right. So, but again, it seems like we have moved away from this, right? When I started, like, you use basic and basic, original basic. Who has used basic here before? No. Who has used go-to before? Who has used go-to statements? Yes. In which language? Yeah, but was it assembly or something? Yeah, you jump, right? Okay. Yeah, you have to do it there, right? So yeah, so go to basically it was not really it was really people thought maybe that you had to have go to, but what was proven actually, it was actually proven, right? Yeah, it was proven. Main point. It was proven that you can do everything that, yeah. So that was a proven. So I don't know if the reference to do reference for this to the proof, right? So C, of course, modern languages, right? We get C, right? Right. So structured program is built in, right? Lots of improvements. So now. Selection statements, right? Of course, we know them. If then else, right? Those were the early ones. Almost every language has them, right? And then we have also sort of improvements on this, like for more, you have multiple case, you have switch or case statements, right? And there are also advancements over that, like pattern matching, things like that, right? So what do we? So first of all. So we have some issues here when we're dealing with language, right? So do we allow Booleans only, right? Or do we allow also truthy, falsy values, basically, right? Some languages only allow Booleans, right? Famously, C lets you do anything, right? It just, it's all zeros and ones, right? It can use them, And also, I think most languages now have let you use, non-booleans as part of switching, right? So, another thing, of course, is the dangling else problem, right? When designing language, of course, right? What to do with this case? Which one is true here, right? If, right? If you don't have Python's indenting rules, right? Where does this else, whose else is it, right? This part here, right? Is it this one or this one, right? I mean, this is when, in Python, like, oh yeah, this is one, right? And this is a, different case. But in general, right, it's not so easy to decide, right? So some language actually had a problem with this, right? If you end up this kind of code, right? So which, is it here or here, right? Where do you think it makes more sense? Like which side?
Wait, what exactly?
Okay, the issue is this. There's this else statement, right?
Yeah, I see, but like it depends on what you exactly want to.
Well, exactly, but the thing is that the whole point is ambiguity. There's not clear. I mean, remember, this is not Python. This is just general pseudocode, right? Where does this else? Is it attached to the second or the first if? Where should it be attached? Where do we expect it, right? Because you ignore formatting, right? Because again, these are like if you format it, right, then you can see clear. Okay, yeah, this one here, this one here. But usually, remember, 90% of language, I don't know, most languages don't have this formatting implemented, right? It's just,
When those languages stop.
well, all of them then suck, right, except Python, right? Right? So no, but I'm saying that.
Well, but the rest of the language is curly.
Yes, of course. So that solves the problem. So so those languages, I'd say probably less than 10%. So those languages don't have curly brace, those suck, right? Yeah. So yeah, you have no way of making sure, right? But still, again, people are lazy, right? And I don't know offhand now what happens in C where does this else attaches to actually, right? It's called control flow, right? It's a problem, right? And if you are designing a language, right, this would be actually a problem for you as well, right? So easiest way is, like you said, add curly braces, and I would say require curly braces, right? And then you don't have a problem anymore, right? I believe Kotlin requires curly braces, right? So, okay, so now we have a problem also is multiple selection, like you have switch or case. What do you do if multiple cases match? Do you allow fall through, right? There is the famous fall through behavior, right? Do you group multiple statements in that selection, right? Also, do you do the lazy eval, short circuit evaluation, right? If something, do you stop, right? Because remember, if A is false, B you don't ever check, right? So that's an issue if you have if B does something, launch a nuclear weapon, right? Then again, B, you might want to run it, maybe you don't want to run it, hopefully, right? And of course, you have ternary or conditional operators, right? So again, do you make certain components mandatory? Like, do you want always at begin and end, right? Like in Pascal, or curly braces? We talked about curly braces just now, right? So, yeah. So Algol introduced these block structures, and I think Algol used begin and end, I believe, sort of Pascal-like. Of course, Pascal is more like Algol-like. And C used curly braces, right? I also had a switch, right? Python, big one on indentation, right? And the thing is, like, it's interesting here. Well, this is not true. When I wrote this, right, or the book actually wrote this, doesn't have switch case. Not true. Actually, now since Python, there's a match statement actually, right? Yeah. Yeah, there's ADA was really, really strong, really, I would say ADA is a really explicit language, right? What you can do, and so. On functional cases like pattern matching, which is very useful in functional language, right? So, of course, we know this one here. Let's run some code. We know we don't need this anymore, right? And so, sky is blue, right? So, this will work or not? Okay, so sky is blue. Yes, 10 is, yeah, so this will work, of course, right? Okay, all right. So, two-way selectors, right? So, if then else, right? Yeah. Switch case. So let's look at this one here. In C and C++, a switch case, right? Kind of handy, right? What is the issue here, right? What happens if I take off this break? What will happen? I don't have this break.
Well,
So, and I have some,
I would imagine that it would throw a syntax error.
no,
It will continue on the other case.
yeah. It's famous fall-through behavior, meaning idea if it matches value 1, right? So it will do something, right? And it will also fall through and could do something for case. It won't check for value 2. Let's say let's say it's 5 or A or something whatever, right? A, right? It will do whatever for A, but it also do for B. And that is kind of interesting. It can be abused basically, right? So basically you can match multiple cases by using this break, or not using break. But historically, of course, I mean, modern thinking is you have to require break after, right? Don't do this in this particular way because it leads to some really messy code and really hard to read code, right? So pattern matching, right? This is a big idea, right? You have cases, right? And you do something. It's kind of similar to case, right? But you actually allow more different patterns, right? So we'll see this in Kotlin, and Rust has it also. Most modern languages have this, right? Also now Python also has it, right? So if else, right, does have. Well, again, you see this old information. I need to update this information. Or you used to not have it. Yeah. Also, since Python 3.10, yeah, let's see if we can see this code. Yeah. So even Python is now on the board, right? Case. So this notice here, there's no break here, right? There's no requirement break because it's automatic, right? It's just single case. So if you think about it, right? If you think about it, this is what's important then is, right? When you do these match cases, right? Pattern matching, right? What's important? Order, right? Because crucial, right? If you do this pattern, if your pattern is like really, so depends, if it's very loose, patterns like match everything, like wild star pattern, right? Joker pattern, then the rest of the case, it will be kind of your code very easy to make a mistake, right? So you need to be specific first, more specific first, right? And then only move on to general cases, eventually ending up with default case. So key with pattern matching. With pattern matching, we want to start with more specific cases. Yeah. Otherwise, we risk. Yeah. Okay. So we use list-based syntax, right? If else, right? Condition for multiple, right? Go, which is going to be your next part after probably in March or April. We'll see Go. And kind of easy, right? Go is the easiest language I think ever, all right? Yeah. So switch case, right? What else do we want to check, right? Oh yeah. One more thing is in many languages, right? Let me change this. Enum will be great. Using enum data type will be make for a great switch case. Why am I saying this? Actually, let me change the code to Markdown. Right now I don't want this and use enum switch. So idea is this. For readability and safety. Yeah. In addition, yeah. Example in Java. I'll do the Java. Yeah. Something like this. Let's take a look. Come on, I need some more code, right? Very simple code, right? Oh, come on, I want to. Monday, switch case. Come on. All right, there you go. Right. So, basic idea is that, so this example, right? It's in Java, but idea being that you limit this, right? So it's impossible to, assuming you make this switch case for something, right? It's impossible to supply a wrong date, basically. I mean, it can be semantically, right? But you won't be able to supply, 8-day or something, right? Or if for some reason you think your code, it will make your code more robust, right? This type of thing, right? So, okay, let's take a break for 10 minutes, and then we'll continue looking at iterative statements, some issues with iterative statements, possibly. Right, again, easy stuff, but some interesting side quests.